Okay, here we go. Now I thought I would give an explanation as to how to compute run hours. As we know, the highest um, increment that we can time in is seconds. So we're going to do some math, and we're going to learn about some math functions here and some other functions for us to be able to keep track of run hours of a motor. So the first thing we want to do is start with the timer. So I am going to add a rung in here. My focus here. Okay. And I'm going to do this on a push button, but obviously this would be on motor contacts. Actually, I'm going to do it on the selector switch so I don't have to hold the button. Okay. And I'm just going to pretend like this is motor status. Okay. Let's say motor on status. Of course, it's going to be our selector switch, but we're just going to pretend. Okay. And we're going to come over to our timer counter, and we're just going to use the time on delay. Okay. And this is going to be a T4:0, and we're just going to call this our motor. Actually, I'm going to cancel out of that because most students are already using that for their spin down timer, so I'm going to go to 1 here. Okay, and I'm going to say motor. Let's say run hours timer. Okay. Okay. Oh, I need to put a M1 RHR run hours. Okay, so that's going to be my motor run hours timer. Now we know that there are 60 seconds in a minute and 60 minutes in an hour. Okay, so 60 times 60 is going to be 3,600. Okay. So every hour, this thing is going to become done. Okay. So that will complete every hour. Let's go ahead and add another rung in here. And when T4:1 is done, we're going to want to do something. And we are going to want to do a math function. We're going to want to add. And I'm going to say that N70 here is going to keep track of M1 hours, HRS. Okay. It's going to be motor 1 run hours. Okay. So here, then I'm going to say N7:0. So that's my motor run hours. And every hour, I just want to add a 1 to the run hours. And I want to put that back into N7:0. Why did it do that? Let's come down here. N7:0. Okay. So it's going to take whatever value I already have in my motor run hours after the 3,600 seconds, add 1 to it, add an hour to it, and stick it back in my run hours. Okay. Let's go ahead and download this. And I'm going to go ahead and make this bigger so All we need to see the panel for is me flipping the switch, and we can see that on the actual screen here. Okay, so we're going to download this. Yeah, sure. We'll call that. Okay, and my switch is in the B position right now, so I should not be timing. Okay, so a couple things here. Number one, we are simulating the motor contacts with our selector switch. Okay, so normally that would be I0.0/7, or if it was forward or reverse, you'd have that in parallel with the reverse button, the reverse set of contacts, I0.0/8. Okay, so either one of those would be on. That would be hours on the motor. So then when I flip the switch, we're going to start timing. Now, I don't actually have to wait an hour. I can actually, while I'm running, actually change this value. So I'm going to show you that. So I'll move it to something just a little bit less than 3600, and we can see how this being done is going to add an hour in there. Okay, so let's go ahead and flip the switch. And now you see that I'm timing. And so the accumulated value here is the number of seconds the motor is running. And so if I double click on it, I can actually change that value. And I'm going to make it 3595, okay? And then it'll just add from there. And when we get to 3600, it added our hour in there. But if you notice, it's done, and every time that we are complete, every time we come around and scan this, it's adding 1 in there, and you can see how fast it's accumulating. So we're going to need to fix that. So let's go offline. Okay, so the problem is that the timer went to done, and then it stayed done forever. What we want is it to be done only for one scan. We want it to be done as long enough for this code to execute, and then when we come back around, we want the timer to actually reset and start timing the next hour. So what we can do is create what we call a self-resetting timer. So we definitely want a time on the motor running, but we also want to reset on when we're done. Then I will have a self-resetting timer, and we're going to look at that here. What's going to happen is, as long as I'm not done, that's what this means, is not done. If my motor's running and I'm not done, I'm going to time. Once I get to being done, the done bit will be set. This will close. I will add my 1 to my N70. Then I come around on the next scan. This is testing for a 0, and that done bit is a 1. It's going to reset my timer. And as soon as it resets my timer, I will then go back to 0. I'll come down here, and I'll clear out my done bit. I'll come down to here. My done bit won't be set, and I won't add that number in one more time. So let's go ahead and download here. And I believe we need to go to run mode. Okay, so we're timing, and we can see that right here. And I'm going to, again, speed up time. Okay, now if you noticed, this incremented that for 1 hour, but when I came back around, my done bit was no longer a 0, it was a 1, so I reset myself, cleared out my done bit, and then I didn't do that add function again, and then I came back around and I started timing again. So that is how to keep track of run hours. The only problem is we're only good to an hour. So if we run for 1 hour and 59 minutes and 59 seconds, if we've stopped and then started, so here, let me stop. You notice when we stop, this gets reset to 0. So if I stop at 59 minutes and 59 seconds and then restart, I'm losing run hour data every time that I do that. Okay, so here's a simple way for us to be able to fix this problem. I'm going to go ahead and go offline. Okay, so if you notice, my time base is 1 second, and we're timing to 3600. Let's look at our time base. Our time base, we can time to the second, to the hundredths of second, or thousandths of seconds. Okay, so if I change this to hundredths of seconds, but I leave this at 3600, that means that actually every 36 seconds, this is going to be done, and we would want to add in whatever value we needed to here. And that means that we would have to add in 0.01 seconds, because our time base, whatever our time base is, in there. Okay. Now watch what happens when I do a check. It's going to give me an error. Remember, integers are whole numbers. And because I'm trying to add something that is not a whole number to a whole number, I get an error. So, how can we fix this problem? Well, it's just another register. If you notice, the last register type we haven't talked about in the data files area is these floats. Some PLC systems call this real. In mathematical terms, these are real numbers. Real numbers are any number you can find on the number line. So you can find whole numbers on the number line, or you can find numbers that have fractions on the number line. So 1.1, 1.001, those are real numbers. In Alan Bradley speak, those are floating point numbers. Float is short for floating point, meaning that a decimal point can float around. It can move left and right, much like we learned to do when we talked about engineering notation. So I am going to replace this adding here with this floating point value, and I'm going to do it down here as well. Come on. And then I'm going to do another check, and that all is well. Okay, so let's review. We changed the time base to, instead of 1 second increments, to hundredths of second increments, and in doing so, we had to change this to the time base as well. So now every 36 seconds is 1/100th of an hour. We are going to add 1/100th to our hour. Let's go ahead and download this and see how this works. Okay. Now, if you notice, this is timing a lot faster because it's timing in hundredths of seconds. So it's going to get up to 3600, and then it's going to add 0.01 to my F8 and store it back in my F8 :0 floating point register. Okay, so you saw that it added that increment there. Now I'm going to go ahead and trip it out here. So I'll make it 3590. And you see that it did it again. And I'll type in again 35. I'll do 75 so you can kind of see it there. There we go. It's still pretty fast. I'm going to do 3500. Okay. So you can kind of see the benefit of doing that. Now, that is definitely accurate enough for us on run hours to get down to the hundredths of hours. Technically, we could actually go down to the thousandths of hours if we wanted to. By changing our time base here down to the thousandths, but that's really unnecessary. Okay, now that we have a appropriate run hour timer at the right granularity, we only need to come up with a strategy for how to reset the timer. Now we know that we can use an instruction to reset this timer. Now this timer is effectively now just a 36-second timer. So we can reset that part of it. I'm going to come over here and put in another rung, and we're just going to use the yellow push button. And this is just going to be our reset timers. And we know from prior jobs that we can use this instruction under timer counter. Actually, I believe, yeah, here it is, the RES. And this one is T41. So we want to come here at T4:1. It's going to reset that timer, but that's only going to reset the 36-second part. Okay, it's not going to reset the actual run hours here. So we need to actually do something in conjunction with resetting the timer, and we can do that at the same time if we have a rung branch around that. And now we're going to learn about a new instruction. This instruction is going to be the move instruction. If you go to the Move Logical tab, the very first item there is MOV for move. And move is a very easy instruction to understand. It's going to move something from a value here to the value there. Now, in clearing out this run timer, what we want to do is just move a value of 0 into my F8:0. Okay? And so that's the same thing as what this is doing. This is just moving a 0 into the accumulated value of our timer. Let's go ahead and download this and we'll try it. Okay, so we'll let this run for at least one iteration here. Okay, so we're up to 5/100ths of an hour now. And we want to test our reset functionality here. So when I push on the reset button, this and this will both happen at the same time. It will reset my timer and it will reset my stored value in F80. I'm going to come up here where we can see them both. So here you can see my timer and here you can see the value in F80. So even while it's running, I can do this and test them both out. Okay, so that is how to implement computing run hours and how to reset both the timer and your run hour value for your future shop jobs. I hope that helps, and we'll see you in the next video.